Now let's consider a very important protocol, security protocol in the internet, in the web, the HTTPS protocol, the secure HTTP protocol. You remember the TCP/IP protocol stack. This is the internet protocols. In that protocol stack, the HTTP protocol is responsible for the connection of the web to the internet. In the protocol stack, for each of the applications, there are an application protocol, and HTTP is the protocol that makes it possible that the World Wide Web can make use of the internet. HTTP controls the communication between the web browser and the internet service provider, service provider that runs the web server. And you remember client-server interaction, that is the principle of the HTTP, of the World Wide Web. And so HTTP is a protocol between the browser, the web client, and the web server. HTTP provides no security. Although it's so important, it only sends the request of the client to the server, and the server sends back the response. All is done in clear text, almost no authentication and others. So network packets are sent unencrypted. Everyone who has access to the internet can see that communication, in clear text. And it is readable for everyone who has access to the internet. And then the second missing part is there is no strong authentication possible. And if you think, for example, for online shopping or for online banking, of course, we need both. We need as well encryption, confidentiality realized by encryption, and we need strong authentication. For that reason, HTTP should not be used if you do serious things in the internet. If you use in web services which get some personal data from you or other things. To the HTTP protocol, there is a secure variant, the HTTPS protocol. This every time should be used if you make use of an internet service which needs confidentiality, which needs authentication. So HTTPS is a secure version of HTTP protocol in the web. All you can do with HTTP, you can do with HTTPS, but you can do this in a secure way. HTTP, to provide the security, makes use of the TLSSSL protocol in the TCP/IP stack, in the internet stack. You remember this TLS was provides security on the transport layer. So the internet packages, all the communication is encrypted, and before the connection is started, there are certificates exchanged to provide a strong authentication. So TLSSSL ensures the encryption of the communication connection, and in this way confidentiality is created, and TLSSL provides secure mutual authentication by means of certificates. So we discussed this already. TLSSL is using hybrid encryption. That means for the exchange of the key, of the session key, a two-key encryption method is used, and then for encrypting the content of the message itself, a one-key encryption method is used with that session key. Now HTTPS can be used to ensure secure communication with strong authentication. So with HTTPS, the weaknesses of the HTTP protocol can be overcome. With HTTP, you can do online banking, you can do e-shopping, you can do government communication, send your text declaration or others. So this is secured, and this need to be applied when you use and perform such services which needs data protection and privacy. What are the working principles of HTTPS? The additional security performance, I already mentioned this, of HTTPS is achieved via the automatically initiated TLSSSL handshake. As a user of HTTPS, you have nothing to do. Automatically, this is part of this, it's integrated into this HTTPS, such a TLSSSL connection is established. In detail, that means the browser, the client sends a hello message, for example, to the online bank, and then the web server of the online bank replies with hello. And in that hello message, the parameters are defined such as, for example, what kind of encryption procedures can be used, what session ID can be used, what TLSSSL version can be used. So it is an offering to the client to select the security methods he wants to apply in communication with the online bank. Together with this hello message, the web server also sends its certificate to the client for authentication. Then the browser starts to verify the certificate, and the most important message in the certificate is the public key of the web server. So the client wants to send encrypted messages to the server, to the online bank, for example, and to be able to encrypt this with a two encryption method, he needs to know the public key of the online bank of the web server. And this is what the browser takes first. And then to schedule a session key, the browser sends a pre-master secret to the web server, encrypted with the public key of the web server. So nobody else to decrypt this pre-master key, with exception of the web server, of the owner of the web server, of the online bank. And then the web server decrypts the pre-master secret, and on the basis of the pre-master secret on both sides, they can compute the session key. So from that pre-master. All the steps are done automatically. So the user has nothing to do. The user, if he starts an HTTPS communication, this workflow is starting. So the TLSSSL protocols used by this HTTPS offer a whole range of different cryptographic methods. The reason is the online bank does not know. Is this a very high-level computer in Connect? Is this a low-level? What are the cryptographic abilities of the user? So the TLS offers a kind of negotiation of the procedures, the cryptographic procedures that are used. So TLSSSL protocol offers different two-key encryption methods. Two-key encryption methods for exchanging the session key. For example, RSA with Diffie-Hellman key exchange, RSA with Diffie-Hellman based on elliptic curves, digital signature algorithms with Diffie-Hellman. So this is a number of two-key encryption methods. TLSSSL protocol also offers one-key encryption methods that can be later used for data traffic protection. For example, AES, Camellia, IDEA, 3DES. So different one-key encryption method. And TLSSSL also offers different hash methods. Different hash methods which later on are used to ensure data integrity. So for example, HMAC based on SHA-1, SHA-256, MD5. Here about these hash functions we already discussed, and where these hash functions are needed or how these hash functions are needed to create digital signatures, we will discuss in a later version. So these are the offerings of the TLS/SSL protocol. There are some more parameters that need to be negotiated between the sender and the receiver to agree on a common encryption method, on common encryption methods for securing the communication between them. There are pros and cons of HTTP. Pros is every internet protocol of the application layer can use TLS/SSL and their security features, so it's not necessary for HTTP to design a secure version, because HTTP in connection with this TLS/SSL layer provides all the security that's needed. TLS/SSL provides an additional and independent layer between the transport layer and the application layer in the TCP/IP protocol stack. And in this way, it remains transparent for the different application. So in this case, if we apply HTTPS, it's used for the communication in the web. Of course, this huge advantages to be able in a very simple way to secure the communication between a web client and a web server, it costs something. It costs because the connection of that security settings takes more time on the server side. So this exchange, this message which tell what kind of cryptographic methods are available, the answer, and such kind of negotiation, it costs bandwidth, it costs time. And also the encrypted data offers hardly an additional options of data compression, increases the throughput. Another disadvantage is TLS/SSL provides an end-to-end encryption between two parties. So it's not possible that this mechanism is used for multi-party services that need to read packages. So TLS/SSL works fine for two parties, but it's not applicable for multi-party services. These are the pros and cons of HTTPS, but of course that we said that HTTPS provides confidentiality as well as authentication, makes it a must for usage of sensible web services. If we look to the development of HTTPS and in detail to the development of TLS/SSL, then SSL first version was developed in 1994 and released by Netscape. So Netscape came with this idea to secure the communication in the web and developed this. For example, in 1995, the second version, SSL 2.0, was integrated into Netscape Navigator. So it was in that version the same key used for encryption and integrity test, and it was used MD5 for integrity test, so MD5 hash functions, which is considered nowadays as unsafe. Then the third version of SSL, they start to integrate certificate validation. This is an important characteristic and needed for secure authentication. It used, instead of MD5, it used SHA-1 algorithm, or offered the usage of SHA-1 algorithm for hashing, and half of the master key depends on the MD5 hash function, which is considered unsafe now, and it provides vulnerability for creating collisions. So this was SSL 3.0, But in all that time, it was an offer of Netscape, and it was a proprietary software of Netscape. And then the international standardization community said it is a very good mechanism, and we should not only use it for Netscape Navigator, we should provide this as a mean to secure other applications too. So they start from SSL 3.0 and developed TLS. And TLS 99 was standardized by the Internet Engineering Task Force as the successor of SSL, and the in-degree protection here was improved with additional keys, so that's different to SSL 3.0. If we look for implementations of the TLS SSL protocol, there we have to mention OpenSSL. OpenSSL, and very widely and popular version of with public source code. OpenSSL became famous because of the heartbleed bug, which caused a sensation that in this security software there was a big and an important vulnerability. Meanwhile, that's closed, so if you are using OpenSSL, definitely you need to use an updated version. Another implementation of TLS is provided by LibreSSL, which emerged from an OpenSSL project, and now further development in the OpenBSD project. Microsoft provide an implementation of TLS SSL, the Microsoft Secure Channel Package. OS X provides Secure Transport Package, GNU TLS. So you see there are different possibilities, different implementation of the TLS SSL protocol. GNU TLS, for example, is a freely available implementation under the GNU license. I mentioned that also HTTPS attacker tried to attack this, tried to attack TLS SSL. So here are some of the famous attacks. For example, Beast browser exploit against TLS SSL. The prerequisite was a violation of the same origin policy. When we discussed injection, then we said to secure, to defend against such attacks, such injection attacks, the same origin policy is very important. And this means that in a website, one should only link to places inside this website. So that's not possible to perform injection to generate content into other websites, so to perform an X-site scripting. The effect of this Beast attack was that it was possible to read cookies and steal TLS sessions, hijacking TLS sessions. That means that after the authentication was done and a secure connection was established, an attacker jumps in to overcome the authentication. Renegotiation, this was another attack against TLS SSL. It allows an attacker in a man-in-the-middle position to combine their own data traffic with that of the client, whereby servers incorrectly identify the client as a sender. So it's possible for the attacker to interfere with the server in the name of the client, and the server becomes not aware that this message does not from the client, that this message comes from the attacker. And then perhaps the most important attack is this heartbleed attack, which allows to read off the TLSSSL application's memory with passwords and other secret information, which allows to disclosure the sensitivity of the data, like password, certificates, and others. So this was a problem this was an attack, and successful attack against OpenSSL. And so you should be clear, if you are using OpenSSL, that you have updated. There are updates available that make it impossible to perform this heartbleed attack. And you remember, we already discussed this heartbleed attack. So here you see it's not attacks against the protocol itself, are attacks against implementations of the protocol.